Welcome back to the channel. In a recent video, I demonstrated how we could find lambda max using a function called idxmax from Pandas. And this is a wonderful data frame or series technique that allows us to find the maximum value and return that index. So let me show you the documentation and then do a quick breakdown of how we can use this technique in other data cases. Let's get started. Here is the documentation for the pandas.dataframe idxmax method. And we can see that we have our data frame. And if we call the idxmax, the default axis is 0, and this will return the index of the first occurrence of the maximum value over the requested index. So if we have axis equals 0, this will return over the index, or axis equals 1, this will return the column. Now, this is a great technique whether you have a data frame or a series if you want to return that index and use that localization for something else in your data chain or some other part of your methodology. So let me demonstrate how I've applied this to my work process. In the original video, I was able to quickly find the lambda max of this data set using the idxmax argument. As you see here, I took one of my data frames, took the average of the data frame, and then used idxmax. So now I'm going to break that down and show you what it's actually doing, then demonstrate how we can simplify a multi-step process using this one method. So now let's switch to this notebook, where we will first import a couple libraries, get our data frame ready, and let me demonstrate what the data frame looks like for you really quickly. If we look at the head method, we see we have wavelengths as our index values, and each of our columns is another standard. So just as before, if we look at this data, we have a series of curves, and I want to find where the lambda max value is for standard 1. So I'm going to call that spectrum and generate that as well. And let's break down what idxmax is doing. If we look at spectrum, we have just a single column or a series, and I'm going to call idxmax. And what this is doing is returning the wavelength or the index value that corresponds to that maximum value. So let's say we did something slightly different. Let's say we didn't know about idxmax, and now I just want to sort the values. And let's say ascending equals false. If we look at this argument here, you see we have our maximum value at the top, and then we have our corresponding wavelength or our index value there. So next, let's just select head equals 1 to get the top row. And let's chain the index method there. And just to make it more clear, let's put a square bracket 0. So this is everything that idxmax is doing all in a single step, where we want this index value so that we can then maybe take that wavelength and apply it to our plot. So in this line here, we are doing all of that to get our lambda max, and then we're going to also get our maximum absorbance so that we can generate this statement here where we have our lambda max at 280 nanometers and an absorbance value of 0.2. The benefit is we can take all this information and make a really nice plot where we can take our data, find the lambda max or find the highest index value, and return it and apply it to this plot. So now let's take another step. Let's say our data frame actually looks like this, where we want the highest absorbance value and we still want to return the wavelength. So let's generate a new spectrum. So let's just call this new spectrum. And let's demonstrate how we can still take advantage of this idxmax argument. So let's do spectrum and let's pass in the column we want, so std1, and let's still use idxmax. By doing this, we get an index value that corresponds to the maximum absorbance value in our data. And so let's just call this max idx. And now we can take our new spectrum, pass in loc so we can use position-based indexing, and pass in our idxmax. After pushing enter, we get this small data frame where we have our standard 1 there, and we have our wavelength. So if we want to just call the wavelength column, we can do that, and we still get our wavelength. So there's many ways that we can take advantage of idxmax. There's also idxmin if you want to find the corresponding index that belongs to the smallest value in the data frame. If you found this video helpful, like, comment, subscribe, and I'll see you in the next one. Peace.